All right, so this is learning test 2 for chemistry, Adele Nolan. Sorry, it's on my phone again. I was having the same problems as before. I'm gonna try and go to the IT desk in the library and see if they can figure it out. But for this learning test, it's gonna be like this again. Okay, so the problem I chose, quote, pure iron is made from the reaction of iron 3 oxide with carbon monoxide to produce pure iron and carbon dioxide. You have 4.84 grams of each reactant. How much iron can you produce? Okay, so I picked this problem because the pure iron caught my eye. At the time when I first picked that, I thought that pure iron was different than just like iron. So I chose this problem because I had no idea that pure iron was a thing. Which is good that I picked that, because this problem helped me realize that pure iron, as I said, is just iron. It's not like its own special thing. So I wrote a note now that I've solved. I'm gonna fix it. Now that I've solved this problem, I realized that pure iron is just iron with a +1 charge. Okay, so what am I solving for? What should my units of measure be? I'm solving to find the amount of pure iron produced from the reaction of 4.84 grams of iron oxide and 4.84 grams of carbon monoxide. So we're given the mass of iron oxide and carbon monoxide, which is the 4.84 grams. We're given an outline in words of the chemical reaction. So it's basically, the original problem tells us the two reactants and what the products will be. Which, as I said, gives us our outline for the chemical equation. And then the units in my final answer, so I'll do the solving part in moles, and that's due to the ratios that are involved with the solving portion. And then the final answer is going to be in grams. It didn't exactly specify that, but I figured since our initial amounts were given in grams instead of moles, they'd be asking for what the amount of iron produced is in grams. So I included both answers. So if for some reason I'm wrong on that, then they're both there. Okay, and then we're solving for the amount of iron in the product. Okay, what information do I need? So I need the molar mass of iron oxide, as well as the molar mass of carbon monoxide. And then eventually I will also need the molar mass of iron, and that's just for the end part of the equation. And then I need the balanced equation, because we were given the chemical equation, just like the names of the elements and stuff, but that doesn't mean that it's balanced. And so you need to make it balanced in order to get the correct ratios. And then we also need the ratios of elements using the balanced equation, as I mentioned. So like, the amount of, say, iron oxide to carbon monoxide based on that balanced equation. And then we'll need to find the limiting reactant. And then I just added the molehill in here because I realized on the problem I did on the board in the class today, I believe I did the wrong conversion factor for the very end. And so I've refreshed myself on the molehill, and in order to make sure that I do it right, I'm making sure to write my units down, because I've just, for Alex and stuff, I've been doing it over and over again. So I've fallen out of habit of some things that I should still be doing. Okay, how will I connect the information I have and the information I need to solve this problem? This will kind of be an overview. I said I will use the amount given in grams for each element, which is the iron oxide and the carbon monoxide. And then I will use that amount given in grams and then use their molar masses to convert those measures to moles. I will then use the ratios from the balanced equation that we mentioned earlier to find the limiting reactant. Once I've done this, I will use the limiting reactant and a ratio to solve for the iron in the end, the pure iron. I will then use the molar mass of this pure iron to convert moles of iron to grams. Okay, so now we're actually doing the work. Okay, so first off, they gave, in the original problem, they didn't give us any, what do you call them? Like formulas for the elements. Yeah, I think that's what you call it. So typically you'd know these off the top of your head, but I just made sure, double checked them because I didn't want to do something wrong. So the iron 3 oxide formula for that is Fe2O3. Carbon monoxide is CO. Pure iron, quote unquote, is the Fe. And then the carbon dioxide is CO2. And then what you'll do from here is you write out the chemical equation that it gives you based on the word problem. And so the word problem tells us that we have the iron oxide plus the carbon monoxide, and then we get iron and carbon dioxide as our products. And then when we balance the equation, our coefficient for the iron oxide stays as 1, but for carbon monoxide, it's the coefficient is 3. And then for the product of the iron, there's a coefficient of 2, and for the CO2, you get 3. And then I do this to help me visualize. I know it's not necessarily needed, but it helps me. I had the mass basically in grams that they gave us in the problem, which is the 4.84 grams for both of these. And I plugged them into the equation. And then on the end here, I have a question mark in front of Fe because we don't know what the coefficient is, or at least what the measure of it is based off of this. Okay, so now that we have that all set up, we have our balanced equation and our idea of what we're looking at based on what the problem gives us, we're able to solve. So first thing we do, we'll take 4.84 grams of the CO, which is here, and then we divide that by its molar mass, which is 28.01 grams per mole. And then what you'll see here, it's easier to visualize when you have the top and bottom division, but since we don't have that, we have to do it like this. That's why I have to solve it on paper before I actually put it in here, because this doesn't work with my brain. Anyway, so what we'll see from this is that the grams, because there's grams on the top and grams on the bottom, they cancel out, which is why I put a little line through them. And then you're left with moles. And when you do this calculation, you get 0.1727953 moles of carbon monoxide. I keep trying to call it carbon dioxide, but it's not. And then, so that's our moles of carbon monoxide. And then we'll take the amount of iron oxide, which is again 4.84 grams, and we'll divide that once again by its molar mass, which is 159.7 grams per mole. Once again, the grams on the top and the grams on the bottom cancel out, and we're left with moles. And our answer for that is 0.030306825 moles of this iron oxide. So now we have it in moles. And the purpose of this is that when we do our ratios using the balanced equation, these coefficients are in moles. And similar to how if you solve a problem with like feet times inches, if you just multiply them as is, you're going to get a number that is not correct. And so you need to convert either feet to inches or inches to feet in order to make them have the same unit so you get the correct measure, which is why you have to convert these gram measures into moles so you can actually use these ratios properly. And that's just easier than taking the ratios and converting them to grams, which is just stupid. Okay, so as I said, once we have the moles of the carbon monoxide and the iron oxide, we find the limiting reactant. So we start with our moles of carbon monoxide. So we plug that into the equation and we multiply that by its ratio. So we're trying to figure out, right now we're only working with the reactants, so the ratio is going to be based off of that. So on the top here, you have 1 of the iron oxide. And that's because when you look at the balanced equation, once again, oh, where'd it go? When you look at the balanced equation once again, you'll see that there's 1 of these and 3 of these. And that's what pertains to the ratio. So once again, you have the moles of CO, you multiply that by 1 of the iron oxide over 3 over the carbon monoxide. And the carbon monoxides cross out, you cancel out, and you get you're left over with iron oxide. When you solve this through, you get 0.057598477 moles of iron oxide consumed. Now, we need to make sure that we actually have this amount to use. So if we compare this to the moles of Fe that we have up here, 0.03 versus the 0.05, we see that this won't work. We will run out of Fe, of the iron oxide. So iron oxide is our limiting reactant. However, I found it's just good practice to solve the other way as well. Even if your first equation ends up being the limiting reactant, I found that when you do the other reactant anyway, it can help you make sure that you didn't do your math wrong. Because if you get two of them that say they don't work and two of them that say they do work, for example, you'll know that either you did something wrong or the problem doesn't work. So I solved the other part anyway. So I have the 0.03 30306825 moles of iron oxide. Once again, you do the equation. We have the 3 carbon monoxide on top and the 1 iron oxide on the bottom. And then the iron oxides cancel out and you're left with 0.090921475 moles of CO consumed. And when you compare that to the amount of moles of CO that we have here, you'll see that we have enough. This is what's consumed. This is what we have. And if you subtract what is consumed from what we have, you don't end up with a negative number. So you know that this just basically reaffirms that the iron oxide is the limiting reactant. It's basically just like checking your work. Okay, so now that we've established that the iron oxide is the limiting reactant, we solve accordingly. So we take the measure in moles of the iron oxide, which is the 0.030306825 moles of iron oxide, and you multiply that by a ratio. Since you're wanting to find the amount of iron, you put iron on the top of the ratio. Once again, if we go back to the balanced equation, we see that our iron oxide, we only use one of these, but we have 2 of the iron in our product. So because of that, the ratio is the 2 iron over 1 iron oxide. And then the iron oxides cancel out. And then what you're left with is 0.0606135 moles of iron. Now, the original problem, it gives us both of our measures in grams. And besides the fact that it doesn't tell us that it wants our answer in grams, because of the measures it gives us, we can assume that our answer is supposed to be in grams as well. So this is the measure in moles that I got, but now I convert it to grams. And as I mentioned in the very beginning, I have both answers here. I need them there anyway, but it's just in case I wasn't supposed to convert to grams. Okay, so you have the 0.0606135 moles of iron oxide, and you multiply that by its molar mass. And it's important that you multiply because you're going from moles to grams. Whereas in the beginning, you were going from grams to moles, which is where the division took place. And this is where the molehill becomes really important, because if you do it the wrong way, you get the wrong answer. And it's, as I said, it's very simple. As long as you get the molehill right, then you'll get it. But I am not great with the molehill, so I always have to look at the sheet to make sure. Okay, anyway, the moles cancel out, so you're left with grams. And when you multiply these together, you get 3.384969284 grams of iron. And then based on the initial numbers that were given at the beginning of the equation, you'll see that it's 3 sig figs for each of them. Those are the only measures we're given, so we can assume that our answer is 3 sig figs. So then when you take this measure in grams and you put it to the sig figs, your answer is 3.38 grams of iron produced. And that's for the equation. Okay, so that's how you solve that. Does my answer make sense? How do I know? I know that my answer makes sense because before I wrote it all down on the computer here on the in-person work I did, or on paper, once I had my answer for this, I solved it in reverse to find the moles of, because we find the moles of CO, because we know that the limiting reactant, when it gets put in an equation, all of it gets used up. So essentially, we just want to make sure that we have CO left over, and if that matches up with essentially what was consumed and what we started with. And those matched up, so I know that's correct. I also I made sure, as I mentioned with the molehill, I double checked my mole conversions. And as I said, with just doing these problems over and over again, I got out of the habit of including some of the units. And I find for making sure that you do your conversions right, especially with moles, but really with any conversions, you really got to put your units. And so I paid a lot of attention to my units and made sure that they were correct. And yeah, so that is my my project. Let me know if there's anything else you need from me. And hopefully I got this right. I mean, I'm pretty sure I did, but you never know. So, okay, bye.